In this session, I'm going to show you how to create a construct from a series of other variables. And we're going to be basing this discussion on our prior session on correlation. So in our rent survey, we actually had 5 questions that were intended to collectively provide data for a construct that I refer to as simply the interior atmosphere of your apartment or house. So I didn't think I could ask that directly, so instead I asked participants 5 questions. I asked them if they agreed with statements about whether or not they enjoy the design of their apartment, whether their friends would envy it, whether it has appealing aspects that they would look for in the future, whether they think it's stylish, and whether or not they want to show it off to their friends and family. So the question is, can we use these 5 variables now to form a single construct? And we're going to use correlation to help us make that decision. So the first thing I could do is graph the data. If I select all 5 of my variables, D1 through D5, SPSS is going to recommend a couple different ways to look at the data. Now we're looking at a lot of variables simultaneously. What it's going to do here with the scatter plot matrix is provide a whole series of scatter plots, one for each of the possible relationships amongst our 5 variables. So the relationship between D1 and D2, D1 and D3, D1 and D4, and so forth. So similar to our correlation matrix from the last session, we can ignore what's going on at the diagonal here. That's simply showing the relationship between D1 and D1, D2 and D2, and what it's doing is substituting in a simple histogram of the data for D1. What we're interested in are these scatter plots, which are showing us the relationship between each of our variables and each of the other variables. So between D1 and D2, it looks like those are positively related, as we talked about in the last session. D1 and D3 look to be positively related, and so forth. In fact, if you were to scan through all of these scatter plots, you would see that for the most case it seems like all of these variables are positively correlated. So let's go ahead now and actually look at the correlation, and we're going to use the same pull down before, analyze, correlate, bivariate, but this time. So let's go ahead now and actually look at the correlation, and we're going to use the same pull down before, analyze, correlate, bivariate, but this time we can select all 5 of these variables, and now we're going to get a correlation matrix that shows the set of correlations possible with these 5 variables. And again, you can choose to either focus on the upper right or on the lower left of the matrix. These are symmetric about this diagonal right here. So looking at the relationships, we can see that it looks as though all of these variables are significantly correlated with each other, as indicated by the significant values of less than 0.001 in all of these cells. Further, we can say that all of these relationships are positive and pretty strong, ranging from anywhere from 0.648 all the way up to 0.86. So it looks like all of these variables are related, and so there's a good argument to bundle them together and create a single construct. There are different ways to do that. The simple way would just be to average the values for D1 and D2 and D3, D4, and D5 into one new super variable or construct. However, there's one more step that we want to go through. There's actually a statistical test that we can use called the Cronbach alpha, and there's a threshold that we'll look at. And anything above that threshold, we're in good position to argue for creating the construct. Essentially what a Cronbach alpha is doing is looking at the set of all the intercorrelations between these variables and coming up with a metric that you can sort of think about as an average of those correlations. So what we're going to do is analyze, scale, reliability analysis. We're trying to test for the reliability of a possible construct. I'm going to pick my 5 variables. And the default is alpha. This is our Cronbach alpha right here. We want our Cronbach alpha to be 0.7 or higher. And here we go. Here's our Cronbach alpha, 0.93. So that's a very strong Cronbach alpha. So now we can go ahead and combine those variables into a single construct. Let me show you how to do that. So we're going to go to transform. We're going to compute a new variable. Give it some sort of a meaningful name. Now we need to tell it how to actually compute the variable. In this case, I simply want the average or the mean of these 5 indicators. You could actually go through here, and there are a lot of different numeric expressions you could use. But in this case, I know that I'm just looking for the mean, and I know what the syntax is. So let me just show you how to do this. Select each variable in turn, separated by commas. Go ahead and click OK. So, my new variable has been created. You can see the new variable is down here. I'm going to go ahead and drag it up just so it's next to the other related variables. You can see the new variable is down here. I'm going to go ahead and drag it up just so it's next to the other related variables. Now I'm going to go under data view, and what you'll see here is our new variable decor next to the 5 variables that were used to compute this construct of decor, which we can now use in subsequent analyses. And again, we could justify that based on the high Cronbach. So let's look at a situation where the data aren't so clean. We also had 5 questions asking about neighborhood. I won't take you through the details of those questions, but just suffice it to say that each of those questions gets to some aspect of the desirability of your neighborhood. So you could visually inspect the data. I'm going to go ahead and look at the correlation matrix for these 5 variables. So I need to deselect what I had in there before, select my 5 neighborhood variables, and click OK. Now it's not so easy. I can't just go ahead and average these 5 as is. I could, but there's some downside in doing that. When you go through and look at the values, you'll see that in terms of significance, some of these variables don't appear to be correlated with one another. N1 and N2 are not correlated. N3 and N2 are not correlated, and so forth. So let's see what would happen when you have some that are correlated. N3 and N1 are, N4 and N1 are as well, and others are not. So we've got a mix of variables that are correlated and others that aren't. So analyze scale reliability analysis. This time we're going to select our 5 neighborhood variables. We have alpha as the default. And I wouldn't expect our alpha to be as high this time. And sure enough, it's not. I have not passed my threshold of 0.7. Now, it is possible to go ahead and average these anyway. You could argue that theoretically it makes sense to group these together, but that's something you would want to identify in your report and acknowledge that you were close to the threshold but didn't quite meet it, and then provide your justification for why you want to keep all of the variables in there. However, there's another alternative. We could go back and look at this correlation table and decide to maybe pull out one variable at a time and rerun our Cronbach to see if we can improve that Cronbach alpha and come up with a better set, maybe a subset of these variables to represent our construct. So if you were to look through this, you would see that one of the variables that doesn't seem to really fit in with the others is N2. It's not correlated with N1, nor with N3, nor with N4. It is correlated with N5, but it doesn't seem to be related to the other 4. So you would go through and sort of identify which of these variables fits the least with the others and maybe pull that out of our analysis. So now what I can do is see what would happen if I excluded it from my reliability analysis. If I took out N2 and reran this. Well, my Cronbach alpha has gone up, 0.69. Not quite at the 0.7, but I'm feeling pretty good about it with just those 4. So what I could do next is go ahead and pick 4 of the 5 variables that I originally intended to include, average those, and create a new construct for neighborhood. So again, we want to take out the second variable. I can copy that text to repeat this function easily. Alright, so here's my new construct of neighborhood. I'm going to drag that up, go to a variable view, or data view rather, and as you move to the right, you'll see our new neighborhood construct, which is an average of neighbor 1, 2, 3, 4, and 5. I'm sorry, not 2. We took out 2.